Do you really believe it's entirely possible that the entire universe started just last Thursday?
I'd say, yeah, I believe it's possible.
What do you think is the probability that we are living in a simulation right now?
It's 41%.
41%. Why not 42%? Will studying on the moon be a thing?
Yeah, absolutely.
Wildest idea you've ever had?
Well, there's too many. 100 years from now, I think there's absolutely gonna be.
Dear future historians, I am your host, Deven. Welcome to Season 1, Episode 1 of our little time capsule from the year 12,025 HE. We are recording this podcast on a quaint, rocky planet you might remember as Earth. Today, we have with us a very special guest who is not only a software and an astrophysics major at the Rochester Institute of Technology, New York, but also my friend of 7 Earth years. Welcome, Aditya.
Hello, everyone.
So, whichever point in space-time you happen to reside in, grab your favorite space smoothie and join us on this odyssey from the depths of our minds to the event horizon. Without any further ado, dear listeners, let's get you up to light speed. So, let's start at the beginning. What first drew you to the idea of studying space and space travel? And where do computers fit in?
Good question. Have you ever had peanut butter and jelly sandwiches?
Well, actually, I've just had peanut butter sandwiches, not jelly.
Really? Well, then this might make some sense to you, but for someone who's never tried it, peanut butter and jelly seem to be two things that would never go together. But in reality, they go together really well. It's a divine combination. And the same is true for computers and space travel. You need all that computation to travel space effectively and efficiently. So that's why I study both of them together. As for what inspired me to take spaceflight and space travel, I've always been inspired by looking up at the sky since I was a child. And just looking up there, I knew for a fact that one day I would go up there and I would explore, and it'd be so great for everyone.
Wow, that does sound very appetizing. So I have to say your degree choice is appetizing, to say the least. Yeah, I will definitely try peanut butter jelly though.
You should.
So we'll come to you looking at space as a child, and I would love to know all about your favorite constellations, but that's for later in this podcast. So my next question to you is, how did your time at RIT shape your interests and ambitions?
So first off, it really broadened my horizons for the kind of things that are possible with like just software and just like astrophysics individually. And then it allowed me the chance to effectively combine the two disciplines together into something that's most useful to me. Well, that's one thing. And
Okay.
the other thing is the exposure to like really good professors and like just peers who are also really smart. So you can basically absorb ideas from them and get help from them when you need. And I think that was a really good experience.
Okay, and moreover, like having finished your school in India with me, and then going to the US and then getting exposed to all that equipment, all
Right.
these people who are building these things. Would you like to share an incident of maybe like a project that you worked on which really sparked your curiosity and, got you deeply invested in space and space travel?
Okay, let me think. So one of the projects that I did was like individually, like on my own time, but I was basically like trying to create a control system for like rocket propulsion. So it ended up being more of like a drone, but it used gyroscopes to control like the pitch of its rotors to keep it upright. And the idea was those rotors could be rocket engines. And
Okay.
if the rocket was going up, it would stay going in a certain direction that I told it to go. Yeah, and I think that was a pretty nice project that I did. That was pretty fun.
Okay. So your project was about propelling it and not launching it. Is what I
So
understood.
propulsion and launch are essentially like similar things, two sides of the same coin. And if you really think about it, like what are your basic rocket engines doing? They're just pushing mass, and a propeller is also pushing mass in terms of air. So they're kind of the same thing, but the propeller is much easier to work with as opposed to like a rocket engine, which would have chemicals around and it might explode. And that's a bit of a hazard when you're doing it like indoors and everything. So that's why I decided to go with like propellers.
So this is definitely not your backyard science sort of a project. I mean, for sure, like you guys must go to some fields, open areas for such things, because if it falls on someone's head,
Yeah, so
then
RIT does have like rocketry club,
Oh.
which I tend to stay away from.
oh,
because
why?
because I like to create all the software and the hardware like on my own, and I like to figure out like what's going. Because when you're in a big project like clubs usually do, you're starting in the middle somewhere. The rocket is already there, and you're working on the avionics, or you're working on like just a tiny little bit of the software, and you don't know the full picture.
Okay,
So
see.
I think at the early stage, it is important to know the full picture of a small rocket, and then move up from there to teams and bigger rockets. And I think,
Got it,
yeah.
got it. So it's sort of like analogous to working in a startup versus working in an established MNC.
Yeah, I think that's a fair comparison.
Yeah. All right. So besides launching rockets and building propellers and all these other sorts of like crazy things that you've done, I believe you have 1 year of college life still left, right?
Well, 6 months.
6 months. That's excluding your co-op?
So 6 months is the amount of credits that I have left. But yeah, it's basically like the amount of credits that I have left that amounts to 6 months of study.
Okay. Got it. So you're on vacation right now. You're back in your hometown.
I am.
So what does a day in your life look like right now? And how is it different from a typical day in the life of Aditya Vikram at RIT?
Okay. So nowadays, I'm hearing dogs. So people from the future, we'd really like to know if there's still dogs in your area. Like,
Yeah,
please let
actually,
us know.
the I don't appreciate these dogs right now.
I mean, like, have they evolved into something? I'd really love to know. Like, have you figured out time travel into the past, or like, we'd love to know that.
Yeah. So if you guys can like send us a signal, like anything works
Send
right
us
now.
a future dog.
Yeah. Oh, but if they do, then it's a paradox, right?
Well,
If
yeah.
they send us a signal. Wait, it's okay. We won't tell anybody. So
Let's save that for later.
yeah, actually, if you figured out a way to make these dogs shut up, that would be really helpful
Okay.
right now.
Too many dogs. Okay.
Yeah. Anyway, sorry. Coming
right.
back to a day in your life.
All right. So at RIT, it's a lot more hectic, obviously. So like I had like a lot of stuff to do at RIT, classes. I was like mentoring people, and like I'm a member of like the Society of Software Engineers, where the idea is that people come to you and ask questions and you answer them and like help them with assignments and everything. And I was making projects, I was grading people. So it was like a whole like litany of tasks that didn't leave much room for anything else, even assignments. So it's a miracle that I kept afloat. But everything is going well on that regard. But now that I'm at home, I have a lot more spare time. So I'm still on co-op with RIT. It's just a remote co-op that I'm working on for a couple of days of the week. But apart from that, I have tons of spare time that I use to create more projects that I'm interested in. So using like software to like simulate rockets and
Uh-huh.
that kind of thing. So I could talk about it in more detail later if you want me to.
Yeah, sure.
Okay. So yeah, that's one of the things I'm doing, and yeah, that's how my days are going. Just working on co-ops and working on my project.
Okay.
But I think you do have to burn the candle at both ends if you like want to like be something or go somewhere.
So essentially, from what I could gather, on campus, you're closer to a professor than a typical student.
I mean, yeah, that might be a fair comparison. Like, sometimes I do feel like that.
I think you're just being modest. Yeah, but running simulations on your computer, rocket simulations, I would love to talk about your plans to, send humanity to Mars or other planets for that matter, later on in this podcast, of course.
Yeah, I'd love to speak about that.
Yeah. So, coming to my next question, how do spaceflight and computer science intersect at your work? Like you just spoke about
Right. So recently, what I've been working on is like a space flight simulator, and a really detailed one at that. So basically, you can like have a rocket, you can define its like basic aerodynamics, and we'll simulate it, like with like gravity and everything. And you can like have certain fuel assigned to it, and you can like basically it calculates its trajectory around Earth and like to wherever you want it to go in real time, and lets you analyze it. So you can like make changes to like the amount of delta V that you have, if you know that what that is.
I actually do
So
not.
delta V is like basically how much velocity the rocket can add to its current velocity. So it can technically be seen as the amount of fuel that you have, and with the kind of engines that you have. So like
Okay.
if your rocket is really light and has a lot of fuel and really good engines, it has lots of delta V.
Okay.
But if it's like big and like small little engines, it's gonna be slow, but it's still gonna have a lot of delta V if it has a lot of fuel. So it all has to do with the rocket equation. So yeah, that's what I've been working on, and it's a perfect example of computers meshing with aerospace and trying to create like a simulation of what happens in the real world. And I think
Wow.
it's pretty
Okay.
fun.
Okay. Very interesting. So, like, two follow-up questions I have. Number one, how do you get the data about the movement of the planets and, because you're calculating the trajectories
Yeah.
of rockets? That's the first question. The second question is, what apps or softwares or programming languages do you use for doing these calculations and running these simulations? And how can someone watching this, maybe someone from India or someone from another dimension, can learn how to do these things and, follow your footsteps?
Okay, so the data for planetary trajectories, or ephemeриds, as they call them, is from NASA. So NASA makes them available on like a terminal.
So it's open source.
Yeah, so you basically log into their like telnet server, and it lets you download like all the planetary data that you need, and then you can like import it into whatever like program you want, or a program that you're creating, and have it be like extrapolated based on physics. Or alternatively, you can have the planets on like rails, essentially. Like you don't need to calculate gravity calculations for the orbits of the planets, because the orbits are like relatively stable.
Okay.
So you can have like the optimization of having the planets be like on rails, so you know exactly at what point there will be based on a simple like elliptical orbit equation,
Okay.
and you can just calculate the physics on your spacecraft.
Okay. So this elliptical orbit, is it the same one we studied during school days?
Yeah, pretty much, just in three dimensions.
Wow, I should have paid attention. Wow, that sounds very interesting. And what was the name of the software again, or the programming? language?
I'm programming it in like C#.
Okay.
And like, the C# is just for like the GUI and everything, but like parts of it are in like what's it calling, an OpenGL.
Okay.
Yeah, that's for the graphics, and like the C# is handling all the physics and everything.
For our listeners, if they want to sort of dive into calculating trajectories and running simulations, then what book or like what course or like is there any resource you would recommend to them?
Okay, so for myself, I like taught it to myself by doing.
Oh wow.
So there's not like many books and courses that I could recommend because a lot of it is just like the simple physics that you'll learn in like 11th grade and 12th grade and like early college, and extrapolate it. You can do it like by yourself, like if you just think about it like
Wow.
a bit harder. And you can like derive those equations from the things that you see around you, most of them especially. So it's just a matter of like numbers and constants and like propagating those equations and knowing how to do that.
Got it.
Yeah.
Got
So
it.
like and one resource for like visualization, but like really good, is game engines. So
Okay.
game engines already support having objects and physics and everything. So you can import all of that into a game engine and they'll do half the work for you. And,
Okay.
yeah,
So
it's
something
pretty
like
fun.
a Unity
Yeah,
game engine.
like Unity.
Oh.
I started building this in Unity, and then I gave up and made my own game engine.
Oh my oh my god. Yeah. Okay, so that's where the software engineering part comes in.
Yeah.
Yeah. Interesting stuff. You know what? Let's zoom out a bit. So, what, according to you, is the most exciting trend in aerospace right now?
Right now,
Yeah. So, is it AI? Is it 3D printing? Or is it like the discovery of new materials, like an alternative to
I think
graphite or something?
I think the biggest thing in aerospace right now is trying to develop reusable launch vehicles. So right now, like SpaceX is the only like real like rocket agency which is way ahead in the game. They have their Falcon 9,
Right.
which is like really reliable and has launched like more than 500 times, I think. At
So
this
it has been launched and caught
Yeah,
about
launched,
500 times.
and landed. So Falcon 9 is not Starship. That's a different. I'll come to that. So Falcon 9 lands itself on its landing legs, on like a barge or on like a pad next to the launch pad.
Okay.
So, and basically the booster gets recovered, and the upper stage is like lost essentially. But they make it like they fabricate new stages like for every launch upper stage. But that's like so the lower stage is like 60-70% of the rocket. So that's like a huge saving that you're reusing, and it needs like really little refurbishment. So other companies are obviously trying to emulate that because like reusable launch vehicles are just the game right now. Like
Right.
if your car broke every time you drove it,
Yeah.
that wouldn't be very
That wouldn't be a
economical,
very
right?
nice car. Yeah.
Yes, so they're trying to make a car that doesn't break
Wow.
every time. Like it just like just need to like refurbish it a couple of times, and then
Wow.
you can just drive again. So there's companies like Rocket Lab that are also trying to do it in the U.S. and like even around the world. China has a ton of companies that are trying to emulate this, and even Japan, Honda just recently tried to create like a first stage that could land itself, and it successfully like launched a couple like 100 feet and landed itself.
Is it?
On a pad? Yeah, it was
Oh.
pretty cool. It just happened recently, actually.
Okay. Interesting.
So that's the biggest trend. The second biggest trend, I think, is in terms of rocket design, is additive manufacturing. So basically 3D printing, but
3D printing.
yeah,
Okay.
but with like metal, obviously, for like
Oh.
creating engine bells, basically having them be more compact, more robust. It does have the downside of being less repairable. Like if you want to repair them, you'll have to cut it open. So,
Got it. Got it. So
that's
okay,
one
okay.
downside. But because they're so well integrated, there is ideally a lower chance of failure on those.
Wow. So are there 3D printers that big that can print a rocket
Yeah,
ship, or
I
do you
mean-
do it in parts?
I mean, like for rocket nozzles, yeah, but there are 3D printers for houses. Like
Oh yeah, I heard that recently. There was some guy in Tamil Nadu or like from some IIT who.
yeah, so
Recently.
even NASA is researching on like 3D printing houses on Mars.
Oh,
Yeah,
so that's gonna save us from the environmental implications of traditional
exactly.
construction.
Exactly.
Yeah.
And yeah, so this is a really big thing right now. Other than this, there's like applications for like satellite swarms, so like SpaceX Starlink for providing internet across the earth, by having just thousands and thousands of satellites in low Earth orbit.
Wow.
So currently, SpaceX has like 9,000 or so satellites in low Earth orbit, and that's like the majority of satellites in orbit.
How?
Like,
How do they not bump into each other?
well, satellites are not that big. They're like, I don't know, like a couple 10 feet or so at
10
most
feet. Okay.
in
Okay.
length, and space is big. Like, you ever see aircraft crashing into each other? Like, there's like,
Let's not go there.
well, yeah, but the point, you ever see birds crashing into each other? It doesn't happen
I
often, does
mean,
it?
unless one bird stole someone
Well,
else's
yeah,
food or
but
something.
then it's a fight.
Oh yeah. Oh yeah.
Yeah, but like the satellites are small and they're really far apart,
Okay. Hmm.
so they don't crash into each other as often. Like, the real problem is when like a satellite breaks.
Okay.
And if it's
and the
like-
debris, they just
Like,
flies
and if
everywhere.
it's like high above the Earth, then the debris will be like everywhere, and it can crash into satellites and can damage them, and it'll create like a runoff effect, which basically could block like ever launching satellites from the Earth without if you don't clean it. It's called a Kessler syndrome. But the thing is, it only can ever happen on really high orbits, and there's not a lot of satellites in those orbits. Most of the satellites are in low Earth orbit.
Okay.
And in low Earth orbit, there's enough of an atmosphere that if something happens, they're just gonna come back down in like a couple of weeks. at
Okay.
most.
Okay.
So, and because like the smaller parts have like a lot less inertia, so the air can stop them, but like there's also a surface area factor, so it's a bit complicated, but they do eventually come down.
All right. But what you're saying is that the possibility of us being stuck on this planet forever because of space debris is a real issue.
Yeah, it's a real issue that's being considered when there's companies out there that are trying to like build solutions to clean space debris.
Oh,
Like there's been ideas being thrown around of being captured in nets.
okay.
And-
Okay. That sounds like
Yeah,
a very
I mean,
like
but
the
they're
first
yeah.
solution you could think of.
But they're traveling pretty fast. So
Oh, yeah.
what kind of net are you gonna make? So
I mean, with
Yeah.
high elastic strength, but
yeah,
also should not burn or break. Or
right,
whatever.
right. And
Okay,
there's more. Like so recently, NASA and like with association with like another agency, I think it was ESA, they launched a solar sail
Okay.
which uses radiation pressure from the sun to accelerate a spacecraft. And these solar sails, like when we use them, that you can accelerate them to like significant fractions of the speed of light, and have them
Okay.
like escape the solar system. Like if you like start from very near the sun, and so they're a pretty effective means of traveling like between stars.
Oh wow. So essentially, if we let's say we achieve close to 99.99%
Well,
the speed of light,
that's too
hypothetically,
high.
then could we travel? Like, could we travel into the future? Or
Not really, because like simultaneity is a thing. So what'll really happen is like you'll get like let's say you want to go somewhere nearby to Proxima Centauri, perhaps. So
Okay.
what'll happen is because you're going so fast, time is gonna stop for you, like from
Right.
the outside perspective.
just
and
like
from
at
your-
the event horizon.
yeah, and
basically.
from your perspective, time is going to stop outside. So when you do get to Proxima Centauri, and you look back at Earth, because you're traveling at almost the speed of light, the light that left Earth is just now catching up. So it'll look like you just left, and because you're looking back at Earth, and light from Earth is reaching you from like the year you went.
Okay.
So it'll look like you just left from Earth, but in reality, 4 years have passed.
4 years have passed.
Yeah.
Exactly 4. You've calculated this?
Yeah, a bit more than 4. So, for, like Proxima Centauri is like 4 light years away. 4-ish.
Okay.
So,
Got it.
A bit more than 4 years.
Got it.
Yeah.
Got it. So Aditya, let's take a minute and summarize these concepts for our users. So correct me if I'm wrong, but essentially a rocket ship consists of two major parts. One is the payload and the other one is the booster. The booster, which comprises of say 60 to 70% of the rocket ship, and the payload is the rest of it.
Close enough.
Okay. And essentially companies are racing to save costs so they can make space travel much more affordable and accessible to a lot of people, which is why they're all trying to catch the boosters, because that's essentially the majority of the cost and it delivers the payload up. So one question I had, we know that energy can neither be created nor be destroyed, same as with mass. It can just be transferred from one form to another. But when you're sending a payload into outer space, are you not decreasing the mass of the Earth? Also, when there's stardust or solar radiation, like photons hitting the Earth, is it not increasing the mass of the Earth?
Well, yeah, it is. Whenever something leaves Earth, it removes some mass from the Earth, and whenever something like gets into Earth, like a meteor, or like in terms of energy, like the mass of the Earth increases slightly. So it's like really measurable. Like, and the more rockets we like push out of the Earth, the less mass will be on Earth. And because the rockets are moving, they're accelerating, and they're like pushing away like hot gases in Earth's general direction. That means they're pushing Earth in the opposite direction slightly.
By Newton's third law.
Yeah, like ever so slightly. And so basically Earth's orbit will change. Well, it'll change on whatever we do. Like if you walk around, Earth's orbit will change slightly. Earth's rotation will change slightly.
Wait, so you're saying me just walking in the park?
Yeah, exactly. And it's a really small effect, but it is a real and measurable, like calculatable effect. Not really measurable, but like it is a real effect. Like when you create a dam in a large river, that creates enough of like a repulsive force that it like modifies the Earth's rotation slightly because of where the water is.
Oh yeah, I've heard this one.
Yeah.
Oh. Wow, that's very interesting, you know. Good to know that me walking up to my washroom to maybe say take a dump is affecting the rotation of the Earth. Yeah, not the best example, but okay. Okay, so hypothetically, or maybe according to the future listeners, you've already achieved this. But for now, hypothetically, if you could design a Mars mission with unlimited resources, what would it look like?
Well, first I'll ask you, does that mean I get to flout the laws of physics, or am I still bound by the laws of physics?
Well,
because unlimited resources implies that I have everything in the universe.
Okay, yeah, so that's exactly it. You have everything in this universe. You cannot travel to another universe which might have different.
Well, if I have everything in the universe, I already have Mars.
No. So, okay, let me rephrase my question. You have a Dyson sphere at your disposal, which is drawing energy from a star as big as the sun.
Okay.
And you have that much energy at your disposal.
I have it immediately available to me.
What?
I have it immediately available to me?
Yes.
Okay.
At your disposal. It's like your it's like on your laptop on a hard disk.
Okay. So in that scenario, why go to Mars? I could just like rip apart Mars and turn it into a spacecraft.
Wait, is that possible?
Yeah.
With that much energy?
Yeah, with that much energy, like you could just move the sun and like have a solar system sized spaceship. Basically,
wow.
if you move the sun, everything else will move with it.
Okay, let's not digress. Aditya Vikram going to Mars on a mission with unlimited resources.
Let's say modern technology to ground it. So if I can have like any modern technology I want to get to Mars, I think what I'll do is have some kind of like nuclear propulsion.
Okay.
So nuclear propulsion is currently like an active topic of research. Like it had a bit of a dormant phase up till now, but it is like back, and I think
just like AI.
Yeah, but yeah, I think it'll be really significant in shortening the amount of time it'll take to reach Mars. Because, like, say now it takes like 6 months to like years to reach Mars. With nuclear propulsion, it could be shortened to like just weeks or just, like a couple of months.
Oh,
yeah, because it has low acceleration, but it can accelerate over a long period of time. which means that even though you're not accelerating much, if you can accelerate for like weeks at a time, you're getting to like a significant portion of the speed of light, and you're just basically ziplining to wherever you want to go.
Okay. Okay, that sounds interesting. So, if you've seen the movie Interstellar, naturally, I think a lot of our audience must have seen that movie. It's by
Hopefully.
Christopher Nolan, hopefully, yeah. But my question to you is, in that movie, the actors, they cryopreserve themselves, or
They do.
what's the right term for it?
I think they did. So yeah, cryopreservation is like a thing that's being researched.
Yeah.
So the idea is if frogs can do it and like bears can hibernate, could some of those like chemical reactions that happen inside those bodies, which make them do that, apply to humans, so that we could hibernate or be preserved, like in like refrigerators, essentially.
Wow.
But it's like I think it's not like a topic that will be sort of possible in the next 10 years or 20 years even.
Got it.
Yeah, so it is like humans are complex. Like
Of
really
course.
complex. So
Oh, yeah.
you don't want to ship humans, and on Mars you're getting vegetables because some
Sure.
like a tiny little thing went wrong, like in your preservation. So I think like it needs a lot more research to make that happen. But humans can survive for 6 months if you just like have like a pressurized unit that is like somewhat radiation proof and has water and like electricity, like
Got
for
it,
solar
got it.
panels, and like a supply of food, like a small farm, so indoors.
Understood.
So basically, if you have like a big structure in space, you can spin it to have like a certain amount of outwards acceleration from the centripetal force. So you're essentially simulating gravity in there. So you can also make gravity in space this way.
Oh.
Yes,
Okay,
but
okay.
it is a bit different from regular gravity because if you get close to the center of your like object, the direction of gravity is going to switch. So it's going to be a bit disorienting.
Understood.
Yeah, but that's probably the best way to have like artificial gravity for long-term missions
Okay.
because we
okay.
don't like we only have like a basic idea of what happens like if humans are in like zero gravity or zero G environments for a long period of time.
Yeah, so essentially we can use centripetal force as a part of a spaceship that's rotating to
as a substitute for
stimulate.
gravity.
Yeah,
But then you're also limited by materials. Like you can't spin it too fast, or else like whatever material you use is gonna break.
right.
So you have to find like a good balance point for how much you can rotate it realistically. Bigger structures need to rotate like on less in terms of like rotations per like hour or something.
RPM.
Yeah, RPM basically. So I think that's something that could happen if like we had a big ship that could go to Mars. Like we could have artificial gravity in it, and we could have farms and solar panels to provide all
Wow.
the electricity, and
Okay.
basically a closed loop ecosystem that takes all the waste, recycles it into like soil, manure, grow plants from it, and like get water back in, and you're getting energy from the sun, and like getting nutrients from like whatever like waste matter is there, and so on and so forth.
So you could do space farming.
Yeah,
Maybe that's a thing. Maybe we have some
yeah,
space
astrobotany.
farmers
Yeah,
who
I
are
mean-
watching this podcast.
Yeah,
Right?
I mean, plants are being grown in space like as we speak.
Oh,
Yeah, like
Wow.
recently India had a mission where they grew plants in space, and China had a mission where uncrewed mission where like they tried to grow like little plants on the moon.
oh,
On
wow.
lunar soil.
Were they successful?
Oh yeah, I think they were like up to an extent.
Interesting.
Yeah, and NASA has grown tons of plants on the ISS.
Okay.
Yeah.
So coming back to cryopreservation. If you were to say allocate the next year's budget for NASA, let's assume that. Would you allocate more funds? Like, how would you allocate funds between achieving speeds that are closer to the speed of light versus cryopreserving? Because both of these things are, both viable options for transporting
Right.
humans
Yeah,
to
there
long
are,
distances.
There are, but I think I'd go more for the speed because
Yeah,
the thing is,
that's what I was thinking
yeah,
too.
like if you like say cryopreserved a lot of people on like a slow spacecraft, and it takes 30 years to get to where you want to go.
Exactly.
And in that amount of time, you're going to have really fast spacecraft. So by the time those people get there, you're already going to have the fast spacecraft at the location. So
Wait, that's a great plan actually.
yeah,
You
so
could-
like, well, why did we cryopreserve them? Like, we didn't need to do that. So yeah, so making changes to the human body, like second objective. Like if we can afford to not do it, we shouldn't like go ahead with it because there's alternatives.
Right.
But if say there's no alternative, like we've already like, reached the speed of light, or we've discovered some kind of warp drive, then we might need to consider it. Yeah.
Okay, interesting. So, coming back to Mars, what, according to you, are the biggest technical and human challenges to making Mars travel affordable? So more people can, take a trip to Mars, like we take a
Right.
trip to Bali or Indonesia,
Right,
or
right.
wait, any other place.
Yeah, so far we've only really discussed the technological and biological challenges, but there's also the psychological aspect of putting a lot of strangers in a tiny enclosed environment where there's nothing outside.
But
And
that sounds awfully lot like Big Boss.
that sounds like 2020,
12,020.
12,020.
Yeah.
Yeah, so that sounds awfully like 12,020.
Etchy. Yeah.
Itchy. Yeah, so it's gonna have like a psychological toll on people unless they're like really trained and prepared for it, or we have some robust entertainment system on board.
Uh-huh.
Like if you're gonna take people on long trips, like trips to Mars, either they're gonna be really fast, so you don't feel as like psychologically like bad, or like you're gonna have like something on board that's going to keep you entertained and keep your mind off like the loneliness of being alone
Got
in like,
it.
a little ship in the middle of nowhere. Like
With strangers.
yeah, but yeah, so that's one aspect of it, and the other aspect is habitat. So on Mars, because the environment is like not like Earth at all, like it's
Of
pretty
course.
harsh. So you need some kind of habitat that is like a closed loop. Like it can recycle everything inside it. It can like generate energy from like the sun or from like whatever resource they find on Mars.
Okay, so
And-
like a self-sustainable
Yeah, a self-sustaining colony.
ecosystem, like
Yeah,
a biohub.
Exactly. So, like on Earth, we take it for granted that we can just plant something outside and we're gonna have a farm. Like,
And it'll grow into something.
yeah, exactly. But on Mars, you don't have that liberty. So, because even the soil is toxic over there.
Understood.
So, it's gonna be like a long shot. At first, like you need a lot of tonnage to Mars, get a lot of payload up there. So I think SpaceX's Starship, which they're developing right now, could be like a solution for a lot of this. Like because it's so big, you could just use it as a home. It's like building size.
Understood.
And because it's so big, it can transport huge payloads. Like I looked at the numbers, and even a single Starship to Mars will carry more payload to it from Earth than has ever been carried before by all like the space missions to Mars.
Wow. How
Yeah.
who made that calculation? Like I'm
mean,
curious to know.
I mean, like the payload capacity, the purported payload capacity of a future Starship is
Okay.
like 100 to 150 tons, and we know the
Oh.
mass of all the landers that we have on Mars, and it's much less than that.
So you said it's 100 tons? What?
100 to 150.
150 tons. So how many humans is that?
So, I mean, if say a human is like 50 kilograms, right? And they need like air, they need supplies, they need water.
Right. Of course.
And-
You have to
so-
factor that in.
So let's say 1 ton per human. Like they have their own room, they have their seat, they have like everything. 1 ton per
Food,
human.
water,
Yeah, food, water,
things
one-
to survive, oxygen
Yeah.
cylinders.
Yeah, 1 ton per human.
Got it.
Sounds reasonable. So that's 150 people.
150 people. So like 1,000 kilos per human.
Yeah.
Oh yeah, sounds reasonable.
Yeah, so
actually.
150 people on one ship. That's a
Wow,
lot.
that's a lot of trips to
Yeah,
Mars.
and that's a lot
To
of trips.
transport everybody.
Yeah, so it's gonna like take a while, at least 10 years
Yeah.
before we start seeing that. But the prospect is really exciting.
Yeah. Speaking of space travel and private companies making it to space, we had a discussion before this podcast that you would like to start your own venture
Right.
in which you make travel to Mars accessible, affordable, and make it sound like, not science fiction, but a reality. So, what role do you see for private companies, perhaps like your future startup, in the space race?
Right. So I think the biggest strength of private companies when it comes to innovation is competition. Like it's basically survival of the fittest in there. So it has like you see the parallels with the space race. Like America only won the space race because it had like a competitor that was also like really good at space travel and everything.
Russia?
Yeah, Russia.
Yeah.
And they were ahead in some places. So there was this motivation. We ought to beat them. Like if we want to survive, if like our ideology is going to win, if we want to be seen as the best.
And their relations weren't
exactly.
the best in the past as well.
So they're enemies for competing against each other.
Right.
To basically control the moon. And like America kind of won, but they didn't go far enough.
Got it.
But that's because the Soviet Union collapsed. Like, had the Soviet Union not collapsed and had they gotten to the moon and started doing something there, I think we would have like cities on the moon by now.
Right.
So competition is really important. And because the competition went away, everything kind of died down in the middle.
Understand.
But for private companies, their entire life is competition.
Right.
Because everything is competing for a market. For money, for like whatever.
There's some monetary incentive to it.
There's incentive to innovate and to like create the best product and for the lowest amount of price that works.
Kind of like the smartphone market.
Yeah, exactly. Like if there was like no competitors to Apple, like we would still have those blocky smartphones. I don't think we would have these thin, slim smartphones that we have today.
Exactly.
Because there wouldn't have been enough pressure to innovate.
Makes sense.
Yeah. So that's one thing the private companies are really good at, and I think governments are now starting to understand that and trying to leverage it. So with contracts with private companies, they like instigate the market a little and like start it up. So that's basically what's happening. And as for the government agencies, I think what their role is going to be is more like oversight and the science aspect of it, because science isn't really profitable in most circumstances. It takes a while to be profitable, so that's something that the government should like take care of for the most part. Right. And oversight, so like the FAA for a flight, NASA will be like for space flight.
Understood. Yeah. So essentially regulations and introducing funds to companies, making it easier for them to get the funds, because of course it's going to cost a lot to put things in space.
Yeah, so regulations, oversight, management of funds, and like keeping the competition healthy, that kind of thing.
Understood. For those of you who made it this far, I would like to let you in on a little secret. We actually ended up pausing the recording of this podcast and had a full-blown 3-course meal just now. So if you are a future historian who's also a time traveler, make sure you comment on this video exactly what we had just now. Sounds good? Yeah? So, coming back to the podcast, let's move on to the next section, which is entrepreneurship. So, you said that you want to start your own aerospace company. So I have 2 questions for you. Number 1, what was the motivation behind starting that company other than taking them into space? And the second one being, what's your vision for that company?
Okay. So for my aerospace company, the reason I want to start one is to basically be present in the emerging space economy and be one of the early go there first to get the worm kind of thing. Early bird gets the worm. Yeah. So basically when everyone else is gonna find out that, oh, we can make money off of this, I'd be already there trying to make money of this, so I might have a head start compared to a couple people. But this is still a while away, so I have a long way to go. But the vision is that one day I'll make basically space travel to the moon and to Mars, hopefully, cheap enough so that anyone can afford it. Anyone who can like afford a business class ticket on a flight
Wow.
should be able to like afford a space flight on the economy ticket. Essentially, that's the goal.
Okay, so how much reduction are we talking? So let's say,
So currently, it's like millions per person just to go to the ISS,
okay,
and that's already a major reduction from what it used to be previously. So as more and more rockets become reusable and the technology matures further in the next decade or so, I think the price is going to come down even more until we're in the hundreds of thousands of dollars range per person. And then when a bunch of people start using it and there's cash flow from like other sources of revenue, like delivering payloads to different parts of Earth, or delivering sort of cargo to and from the moon, that's going to subsidize the other expenditure of like ferrying people to and from like the moon and Earth, and that's going to make it affordable in quotation marks.
understood. So before we start having factories that produce consumer goods on Moon and
Yeah, we
Mars,
need to get them there.
we need
like-
to get them there.
Yeah,
So
so we need like some kind of like a reusable spacecraft that has like really high mass to orbit, mass to moon, and SpaceX is pretty much the only company that's really having some progress in making one right now. But I think China will also be involved in the future, like pretty soon.
and what about Russia?
And Russia, I don't think Russia is going to be able to make it.
Okay, that's
They're broke. Like their space program is broke. And-
what about India? India is known to do
Yeah,
it
so-
at a very affordable cost.
Yeah, that is true, but I'm not really confident that we'll have the technical expertise required for that, and for like 10 years at least, like 10
Right,
or 20 years.
understood.
It'll take a while because we haven't even put like a person in space yet, and even that's been like pretty challenging too. So to create like a spacecraft that's bigger than the one we have, it's going to be a bit difficult, like a lot difficult. But we do have like, so the missions that India has
Yeah.
done already and has planned, they are promising. So like there's signs that things will happen in the future, but it's still like a bit away.
Understood.
So like once we see the first people go to space, like go to low Earth orbit from ISRO, that will be like a tipping point where there will be a lot of interest, and like people will be like sort of rejuvenated and in their dream of Indian space travel, and they'll like realize, okay, this is a thing that we are now able to do, and we can profit from it, hopefully.
I think some people did go to space. ISRO did send some people to
No,
space
not
very
ISRO.
recently.
Not ISRO. So there are Indian people who have gone to space, but they're from like they go with NASA or
As a
with
part of
Russia.
other missions,
Yeah,
basically.
like
Understood.
basically with other space agencies who have the resources and the capability to send them to space.
Right.
India does not have it right now, but
Right.
they're like in active development for like the past couple of years.
Got it.
Yeah.
So to summarize, India will get there, but it's going to take at least 10 to 20 Earth years for that to happen.
So
And
I
you
think
wanna-
the first Indian like crewed space flight will be in 2 years at most.
Okay.
Like a prototype. We sent like 2 people up there and put them back. I think that'll happen in like 2 years or so.
Okay.
And then to scale up from that is going to be the challenging
Got
part.
it.
Because the capsules, I don't suppose they'll be reusable for their first capsule. And they're going to be launched on like the PSLV or the GSLV, which is not a reusable
what are
launch.
these two?
These are Indian rockets.
Okay.
So these are not like reusable launch vehicles. So there's like potential for improvement there.
Understood.
Yeah.
Okay, got it. So coming back to software engineering, what skills from software development or software engineering and computer science do you think are the most critical for a space entrepreneur?
Right. So I think the most important aspect of software engineering and computer science for someone who's like trying to make their own rockets and trying to make their own like space infrastructure is low-level programming. So programming on like the bare metal hardware.
Like assembly or machine code?
Well, yeah, more or less.
Oh my god, really?
And yeah, and like having that experience of like connecting things up to like like basically a bare metal and have it work and control it using your own logic or using like actual like machine control software, like working with it. I think that's a useful skill that only like software engineers are more likely to have. And
Okay.
then there's like basically project management and like basically agile and everything that has to do with like working in a team.
Got
That
it.
is like pretty important for any project. And because space projects are like such a big scope, it helps a lot to have those skills.
Right. So planning things out
Yeah, so
and
I think like a bunch of majors will also have these kinds of skills, but doing software sets you up on like a different level of having be intimately connected with the hardware itself, like having knowledge of it and developing it, and so basically you know a good chunk of the picture
understood,
of the
understood.
rocket.
And also it inculcates a sense of discipline and structure when it comes to
Yes.
building things.
Yes, but I suppose that's like a bunch of majors, like business majors and like say economics majors. I think a bunch of majors do have that kind of like making a project at the end of your like a senior project essentially.
Got it. Got it.
And like you're working in a team, you're on crunch, and you want to deliver a product. I think like that aspect of like college itself is pretty useful in this regard.
Understood. So speaking of business and economics, how do you personally balance dreaming big with the practical and sometimes harsh realities of
Right, so,
engineering and
yeah.
business?
Yeah, so me having both majors, software engineering and like astrophysics and everything, that really ties into that. So because this goal of making rockets is like really big and really ambitious, and to achieve that, you're gonna need like a lot of cash flow, a lot of like resources, a lot of time. So having sort of a safety net or a first step of the ladder as being like a software engineer somewhere, like perhaps with machining, perhaps with like manufacturing, that's gonna elevate me to a position where I'm working in an environment where I'm using my software development skills to like mess around with machines,
Okay.
and it's also gonna make money in the meantime. And then I can use those skills and that leverage to create, like, to build off of that and have my own like rocket manufacturing kind of thing. So it's gonna work like in both directions. It's also gonna be a safety net, and it's gonna be a stepping ladder to.
Okay.
So small goals like those can lead to the bigger goals that I have in mind.
Got it. Got it. So is your vision as of now to manufacture these rockets yourself, or is it to develop the tech behind them and get it manufactured by someone else?
Yeah, so right now, the mission really is to have like flight control systems and all of that. Basically, understand all of those. And once I have that, then I can start with like a small satellite, a CubeSat, and have it like sent to space and have my sort of avionics and everything be tested in space. And then
Okay.
when I have that, and I can start creating like smaller rockets to just go up in the stratosphere, release like something or the other, and
Okay.
probably land back on like propulsively. And then I can go on making like actual rockets.
So speaking of, your own project, like a CubeSat, you said?
Yes.
So what exactly is a CubeSat?
So a CubeSat is basically a microsatellite that can be built by like anyone, and then because it's so small and so light, it doesn't cost much to get it launched on someone else's rocket. You just hitch a ride. Like,
Okay.
You tell them, okay, I have this little satellite, and I'll pay you $1,000 or so, and just launch it.
Just $1,000.
Yeah, like launching small sats is very cheap
Okay.
because they're small, like they're light, and a single launch can fit so many of them. Like it makes them money. Like either way.
Understandable.
So they can be pretty cheap. The hardest part of building a CubeSat isn't like it's more of the regulatory side, like getting approvals from the FAA or the FCC for like communications, getting it approved, and making sure like they want to make sure that you'll like it'll re-enter safely and not like disturb like the atmosphere or something.
Not crash into someone's head.
Yeah, and the radio emissions from it will be safe and not affect anything else. So all of that, and you'll have to get it approved by your like local regulatory body on whatever like country or planet you live in, and then you can like actually build the thing and test it on Earth and make sure that it does satisfy all the requirements, get it approved, and then you can launch it. So that's the hard part.
Understood. So speaking of small satellites, something like Starlink, I think you said there are about 9,000 of those satellites.
Yeah, roughly.
Okay, so how big are those?
They're like not that big. They're, if I remember correctly, they're like a quarter the size of a bus, half the size of a bus, somewhere in the middle of it.
Okay, understood.
So not too big, but they aren't small. It depends on like what you want to call the satellite, because their solar panels are huge, and if like you do want to include that as part of the satellite because it's so thin, but the satellite itself is pretty thin. Like it's basically almost flat and rectangular, and then there's a solar panel at like 90 degrees from it. So
it's like a dinosaur, essentially. Like small body and huge wings.
Yeah, it's like if you look at it from afar, it's like a piece of paper folded like 90 degrees in an L shape.
Oh, interesting. So solar panels to power it,
Yes.
and for solar sailing.
Yeah, not for solar sailing.
Not
like,
for solar sailing.
yeah.
Okay, that's
Those
to
panels-
travel to
yeah.
different galaxies.
And for solar sails have to be really light and really thin, like microscopically thin.
Okay.
And the sails themselves, and they have to be really big, so that they can actually like collect enough radiation pressure from the sun to accelerate.
Got it. So thin, lightweight, and being
Lots
able
of surface area.
Lots of surface area. Got it. What's the most valuable lesson you've learned from, let's say, a failure or a tough project, or maybe a project in which something did not go according to plan?
Okay. Yeah, so I think the most valuable thing that I learned was like learning to trust a team, because I'm the kind of person who works like on my own, alone,
Okay.
and I trust myself the most with whatever I'm doing. But for like big projects, you can't do everything, or even if you can, it's going to take a long time, as opposed to like a couple of good like
Great minds
great
working
minds
together.
working together.
Yeah.
Exactly. So what you want is to build a team that you can trust, first of all, because not all teams are trustworthy. Like
Right.
some people don't want to work, some people have other priorities. That's fine. It's their life. But you want to find people who want to do this with you.
Who are
And-
genuinely passionate about
yes, and
the same thing you
and
are
who have
passionate
skills that have some overlap with you and some that are unique to them. So they
Got
can
it.
bring something to the table, and you want to learn to trust them with something, and they want to and you will learn to be trustable to them as well, trustworthy to them.
about. Like a good leader, you
Yeah.
should lead by doing
Example.
things yourself.
Yeah.
Example. Yeah. Got it. It's interesting. So collaboration, essentially, is
Yes.
one of the hardest things. And nothing technical so far?
So in terms of technical, the projects that I've like most been involved with were software projects, like for like classes and for like my co-ops, and so I like mostly learned about like software design and architecture there, which is not really relevant to rocketry, but was relevant to software, like how to like be in like collaborate. Basically, it was mostly collaboration and how like a big project works, like the basically the innards, the semantics, and everything that has to go into making a project, and
Okay.
to be put in the middle of a project that has already been worked on, a big project, and,
Okay.
and extending upon it in some way that is consistent with how it was previously, but also adds to it whatever you want to add. So that's a difficult balance to achieve and a difficult thing to learn. But I think that was one thing I learned really well while doing these like sorts of projects.
Got it. Makes a lot of sense, yeah. All right, let's move on to the next section now. What do you say?
Sure.
All right, it's time to get weird. So you love discussing theories that sound insane but have real scientific backing. Is that correct?
Well, sometimes they are insane, but happen to have some kind of scientific backing.
All right. So how about we rapid fire through some of my favorites from our previous discussions? Number 1, qualia. Do you think machines or aliens could ever experience consciousness as we do? For example, AI in its present state, or generative AI for that matter, it's essentially a glorified autocomplete. Is it possible that later on it can develop human emotions and feelings like the movie Her?
Yeah, so the big problem with qualia and consciousness is that you can only ever know if you yourself are conscious.
Right.
You can never tell if someone else other than you is conscious. So what if the human brain is just an autocomplete on steroids,
Oh
like
my
an LLM,
god.
and it's just responding to like input and giving an output. Like there's no way to know if anyone other than you is actually conscious. Like everything you say to them, everything that you show them, and all of their reactions could just be the output of an LLM. But there's no way to know that because you can only ever be in your own mind and never in someone else's. So that's basically the gist of qualia. And your experience of the world could be completely unique or completely alone. I see this color like in front of me as yellow, and it looks yellow to me, and I have learned to call this color yellow. But if I were to somehow hop into your mind and see what you see, this might look red to me, and
Exactly.
you've learned all your life to call this color yellow. So we're calling it the same thing, but it might look completely different to us.
Exactly. So I like to think of this as the Windows XP wallpaper, if you remember the classic one. Essentially, at the top, we have the sky, and at the bottom, we have the grass. Now, we say grass is green and the sky is blue, like all 8 billion people of Earth. And you point at the sky and you say that is blue, and then you point at the grass and say that is green. Everybody collectively agrees, but exactly, you can't hop into someone else's mind and see what their green looks like or what their blue looks like.
Exactly. And that is qualia, their individual experience of how they're perceiving these things. And as far so far we don't really know if like AI or aliens, like if we can't even know if someone else is conscious, can we ever really know if AI or aliens can ever be conscious? Because they could be conscious right now or they couldn't. Like there's no boundary layer to this kind of thing.
Also, like if I want to walk or if I want to grab a bottle of water and drink from it, then I don't need to think about every single movement of every single one of my muscles and bones. I can just think about drinking that water and my body just does it for me, you know? Or same goes for walking or talking
Right.
or
And
any other
breathing,
action we
and,
do. And
like
reading, yeah.
digesting food and like all of that internal stuff that's happening in our body, that's not really controlled by your conscious brain. So what part of you is even conscious to begin with?
What part of you is you?
Yeah, exactly. Really difficult question to answer, and I don't think there's an answer for this.
Speaking of brains and consciousness, let's talk about Boltzmann brains. How likely is it that we're just a random fluctuation than a product of cosmic history and there was actually no Big Bang? How do you sleep at night with that possibility?
Well, I think like it's actually more likely than us like 8 billion people existing. Like so a single brain is already pretty complex, as we can see when we look like at neurons, we look at microscopes, and we look so it's really complex. It's the most complex thing we have ever seen.
Exactly.
So how much more likely is that there are 8 billion of them? There's just one of them, like just that it just appeared a second ago, and it will disappear the next second, but it appeared with all the memories and all the sensory information that it has right now. So it will think that it has been here for like ever.
So sorry to
however long.
interrupt you there, but can you just tell us in one line what a Boltzmann brain is before
Yeah,
you
so
explain all this?
basically, it's a kind of brain that has not like it just popped into existence for a short amount of time, and then it disappears. That's basically it.
But why would it want to do that?
Well, it doesn't want to do that. Like, do electrons want to go from one place to another? Not really. And do electrons want to quantum tunnel from like one part of like a wall to another? Not really. Like they don't have wants or anything. But quantum effects are random. So,
Right.
like, what are the chances that through just quantum effects alone in an empty universe, a brain just emerges and out of nowhere, as opposed to 8 billion brains emerging out of nowhere? The probability of the first one is pretty high compared to the second one.
This actually reminded me of a quote by Richard Feynman. He said this in the context of investing. Imagine how difficult physics would be if electrons had emotions. Yeah, I think what you said is absolutely right. This next one is my personal favorite. It's Last Thursdaysm. So today is the 26th of June, 2025, HE. What if the entire universe started last Thursday, exactly 1 week ago, and every single memory that you have was implanted and it's actually not real? Aditya, my question to you is, do you really believe it's entirely possible that the entire universe started just last Thursday?
Well, belief is a strong word for it, but I'd say, yeah, I believe it's possible.
Are our minds nothing more than a cosmic glitch?
Equally likely and unlikely.
And if things go to your liking, one day we might be able to log into, say, Take Me to Space with Aditya.com and buy affordable tickets to the moon and Mars, perhaps?
Well, I mean, the domain name could be a bit better. I'm open to suggestions, by the way.
Okay. Well, moving on to the next one, the many worlds interpretation. So if every quantum event creates a new universe, somewhat like a branching of universe with every single decision you take, for example, eating cereal for breakfast as opposed to pancakes creates an entirely new universe. Keeping that context in mind, what does that mean when it comes to free will, destiny, and ethics?
Well, I think we should elaborate more on why it would create a new universe on every quantum event. Basically, physically, what it means for something to happen, anything, is that all alternatives of it also happen simultaneously.
Okay,
In any way it could happen, and it collapses into the one that we observe when we do observe it.
understood.
So, like light, for example, it said that it takes a straight path. Well, that's not really true. It takes every possible path, and all of it basically collapses into the path we see, which happens to be a straight path. But there's because all of these events are happening simultaneously, it can be thought of as if there's a universe where that event occurred instead of the one that we saw where light took the other path that was not straight. And basically that's the many worlds in the interpretation. And so what this means is every little quantum event, like every little vibration of electrons and every sort of quantum tunneling, essentially it looks like it creates a new universe.
Okay,
And the thing is, because if we were to believe that this universe was created, this means that every possible decision and every possible thought has already been thought and has already been created. It's like the Library of Babel, for instance, where everything that can possibly be written, possibly said, already exists, but not in our world. So it doesn't do much for the free will part of the argument, because in our world, even if we're just like chemical reactions and moving electrons inside our brain, but then there's quantum effects, which really sort of are random as far as we know. So it's like throwing dice in there. So as in terms of free will, that's the part that is free will. Everything else is deterministic.
so do you think all of this talk about perception could be a bit difficult to understand at first glance?
Well, I hope so, because in reality, something being difficult is the joy in life. If everything was easy and simple to understand, would we even have fun? Would we even be people? There's meaning in hardship and difficulty. Sisyphus, for example,
Oh,
He
the
is
boulder of
yeah,
Sisyphus.
he's
Yeah.
constantly rolling up a boulder up a mountain slope,
Yeah.
but like it's his purpose in life. So like he's doing pretty well. Like he's pretty happy. So difficulty, like say if he was like doing nothing, he'd be bored of his mind. Probably.
Exactly. Exactly.
So like even a bit of difficulty mixed with like the moment of understanding, or even understanding a little bit of it, is like basically the spice of life.
Interesting. It gives life purpose, I guess.
Yeah.
It gives people something to kill time before their inevitable end. Are there any other quote unquote crazy theories that you wish more people took seriously?
Well, there's no end to crazy theories. Like
Okay.
one of them that I'm really fond of is that there's only like a single one of each elementary particle. So there's like only one proton, one electron, and like one photon in the universe, and it's just like teleporting everywhere. So that's
Wait,
basically
what?
yes, and that's basically building up the universe as we see it.
Essentially, if there's an oxygen atom, that's just that same proton, that same neutron, that same electron, just
Teleporting everywhere.
teleporting, being everywhere all at once.
Yeah.
Wow, that sounds very interesting.
Yeah, and it's ridiculous, but it's pretty fun to think about. What would change if it were true, and what would change if it wasn't true?
Every single thought that we have it's essentially an electrical signal, which is the movement of electrons.
Yes.
So, what if everything, including the movement of atoms, electrons, subatomic particles, is predetermined, and we are essentially just a superposition of atoms without any free will or any destiny?
Well, yeah, but what changes that is quantum mechanics, which is truly random. So you can't have like a deterministic system with quantum mechanics. In quantum mechanics, like every particle is basically a field of probability where it could be, but there's no way to know where it is. Like if you like try to observe something, like say an electron, how do you observe an electron? Like by like
Shining a photon at it, hitting it
but
with a photon.
if you like shine a photon at it, it's gonna add energy to it. So now it's somewhere else.
Exactly.
So you couldn't measure it. And if you like, so that's the uncertainty principle. Like you can only measure like position or like velocity at one time. You can't measure both of them at the same time.
Understood.
But those two are the things that define where a particle is supposed to be and where it will be. So because both of these can't be known at the same time, there's this element of complete randomness. And that's where free will hides, essentially. Like, even if everything else is deterministic, like F equals ma, and we're gonna move this bit much if we like put this much force, there's still gonna be a little bit of quantum improbability, like just at the edges. So everything's gonna be a little bit different every time you do it.
So electrons can have feelings. Not the best conclusion, but I think that makes sense. How does engaging with speculative science theories like these ones make you a better engineer or a better entrepreneur?
So the thing is, when you engage with like theories this wild, they still have like a bit of science to them, or like they're thought experiments of kind. You're exercising your brain essentially, and what you're doing is you're building like the more you know about like say physics, the more you're applying it, your knowledge of physics to these theories and seeing, okay, this works like as I know it, but what if I like apply this principle to it? Will it still work? And that's the kind of thing that's really important in like science and engineering, to apply like to have what you know and to use it to figure out what you don't know, like induce what you don't know, like in math and induction. And for science, to have what you know and use it as a launch pad for what you don't know, and observe and experiment and try what you know and compare it with everything you see and reaching a conclusion from that. So I think engaging with these kind of speculations is really
a healthy
healthy exercise, and it's fun to do.
Exactly. You never know, some of these theories might actually be true, and before it was proved that F equals ma, or well, people believe that the sun revolved around the earth and all other planets for that matter.
Yes.
And if I'm not wrong, some people were hanged for opposing that idea.
Yeah.
So essentially, all these quote unquote crazy or speculative theories might actually end up being true in the future and would make us look like idiots right now for calling them stupid.
Yeah, we're limited by our knowledge of today. And basically, in the future, that could change at any point. And all we can do is hope that in the future, whatever changes, it keeps everything consistent. That's the best thing we can hope for.
Hopefully, whoever is running the simulation doesn't release an update which breaks physics as we know it.
Oh, what if they set pi to 3.1?
Like a rational number?
Yeah. It's going to cause havoc.
Oh my god.
What if they set e to pi?
E to... Oh my god. I don't even remember the value of e.
Oh, it's 2.71.
Okay, got it. Well, that being said, let us move on to the next section, which is games and pop culture. My next question to you is, do you have any recommendations for games, movies, TV shows, or any other forms of media that deepen one's understanding about space and science? And have you ever consumed such forms of media? How have they helped shape your perception? And were you ever fascinated by Rick and Morty? Or Back to the Future, for that matter?
Well, I have a confession to make. I have never watched Rick and Morty.
What?
Yeah, but I have
my
watched
God.
Back to the Future.
Okay, let's hope the first statement changes before season 2 of this podcast.
Well, you hope, but if I've not watched it so far, who knows if I'll ever watch it.
Right, but you've seen Back to the Future.
Yes, I
All
have.
3 parts?
Yeah, and I love it. It's the best movie ever.
I don't think the third one was good.
It
that
was
good.
alright.
It was alright. Yeah, I love the first one.
Yeah, the
Don't get
first
me
one
wrong.
is like peak cinema.
Oh yeah, for sure.
Yeah. So I think the most interactive something is, the more you can learn from it. So in terms of interactive stuff, you have games, like for the most part.
Right.
And a couple of games that I can really recommend that play with, like perception, for instance. Like one of them is Superliminal. Well, and what this game is about, well, without giving too much spoilers, you're basically solving puzzles that have to do with how you perceive things in your visual field of view. So if you have like a small thing close to you, it'll look really big. And if a big thing far away from you, it'll look really small. So this game
Right.
plays with this kind of perception where if you pick an object up and it's really far from you and you place it somewhere close to you, it's gonna like become bigger, basically.
Right.
So that's the idea, and vice versa. So it's like mind-bending and it's fun, and you like basically learn something about perception from it.
So it's the same as holding a balloon, say 5 feet away from your eyes, and then slowly releasing the air or deflating it as you move it closer to you. So essentially, that keeps the size of the balloon, from
Yes.
your perspective, the same.
Exactly.
But from the perspective of a third person or an observer who's standing and looking at the whole thing from a different angle, he can clearly see the balloon getting smaller. But from your perspective, nothing changed.
Yes, exactly.
What can the world of gaming teach to real-world engineers and scientists?
So, to real-world engineers and scientists, most of the games that they'll find really useful are puzzle games and simulation games. So, for puzzles like Superliminal, there's Portal, and like that entire line of Valve games that are puzzles.
Okay.
And engineers find them like really fascinating because they love dealing with puzzles. And the other part, simulation, there's like space simulation games, air flight simulation games, and all sorts of physics simulation games. For instance, one of my favorite games is Orbiter, and other one is Kerbal Space Program.
Okay.
And these
so-
games are like really fun, like easy to use, like space simulation games for like that are approachable by everyone.
Okay, so are these on mobile or laptop?
So these are like PC games.
PC games.
Yeah.
Okay, understood. And like, do they require any sort of GPUs
Well,
or heavy
they're
computations?
old games, so you'll be
Okay.
fine. If you have a like a
If you have a
semi-modern
floppy
computer,
disk.
like, you'll be fine.
Even with the floppy disk?
Well, not with a floppy.
Not
disk,
with the
but-
floppy.
but
Got
yeah.
it. I'll look in my grandpa's old garage for a decent-ish PC.
Well, yeah, but there's versions of these games. Like for instance, Microsoft Flight Simulator, the old version, it can run on MS DOS. I'm pretty sure. So
Oh, so it can run on a toaster as well.
yeah, a modern day toaster.
Modern day toaster, of course. Speaking of toasters, totally unrelated, but if you could adapt any sci-fi technology for real life, I'm talking anything, for example, even Green Lantern's ring for that matter, what would it be?
I think it would be Alcubierre warp drives.
Okay, I have no idea what any of those words mean,
Well,
or if
okay.
that was if that was one word, or let's start with if that was one word.
No,
or
that was
a
3
few
words.
That was 3 words. Got it. Thank God.
Okay, so basically, Einstein's field equations for general relativity, like they have like everything to do with the curvature of space-time.
Okay.
And you can basically like put numbers of like everything, like the state of the system you want in them, and it spits out like basically what the space-time around that region looks like.
Okay.
But you can also do that in reverse. You can put in a space-time geometry, and we can pull out like what kind of like gravitation fields and everything that would be required to make that kind of thing. So basically, this guy Alcubierre put in a kind of field where space is contracted in front of you and expanding behind you. And basically what it does is, in theory, it creates a kind of warp drive.
Right.
Now, the thing is, it may or may not really work. Everyone's not really sure. But it does seem to be a valid solution to these field equations. So it might be possible, but it takes a lot of energy to like actually get it to be like that.
Okay, so what are the implications of this? Is it faster space travel due to...
Yeah, so if it works as advertised, it means like basically faster than light space travel.
faster than light space
Yeah,
travel?
because you're stretching space behind you and squeezing in front of you.
And essentially, light needs a medium to travel. That medium
Well-
being space.
Well, space can travel at any speed. Like space doesn't have a speed limit. Matter does. But if you're stretching and squeezing space, that means you can go at any speed in theory.
Got it. Well, this question should have been in the crazy theory section, but what do you think? And I need a numerical value. What do you think is the probability that we are living in a simulation right now?
Oh, the probability. I think
No vague answer. I need a number from you.
I think it's 41%.
41%. Why not 42%? Isn't 42 the answer?
It is.
Isn't 42 the answer to
It
everything?
is.
So
One less than that, just to
one
be
lesson,
safe.
just to be safe. Wow. Amazing. I won't ask for an explanation for that number.
Yeah, basically, my alien friends told me that.
Oh, did they time travel to tell you that?
Yeah, they injected it into my brain from Mars.
Wow. So is a bunch of other useful information also a part of your semantic memory now that you have no recollection of?
Maybe.
Maybe. Maybe we'll...
Yeah, they just inputted a lot of text into my LLM.
Wow. So I think you have a really good system prompt, right? A good modified one by aliens, for sure. Well, with that being said, let's move to our rapid fire round. Now, rapid fire means rapid fire, no thinking, quick answers, no overthinking.
Okay.
Got it? So, first question. Favorite space mission ever?
Apollo 11.
Apollo 11. Why?
Well, it's a basic answer. It's the first time people stepped on another like body above, like beyond Earth. It's pretty cool.
Got it. Second question. Most mind-blowing physics fact?
I'd say it's a black hole. It's like how they form, gravitational lensing, and everything about like the curvature of space-time. It's just mind-blowing because you don't really think of space as something that can curve because things curve. How does space curve? But it does curve and it affects how time behaves around space. Like for instance, the closer you are to Earth, the slower time is traveling for you, and the further away you are from like a gravitational body, the faster your time is.
So essentially, when you're at the event horizon of a black hole,
Yeah.
time stops.
Time stops.
Wow.
And at the event horizon, basically space and time flip their positions. So the singularity inside the event horizon is not in front of you, it's in the future. And there's no escaping, like you can't move away from it because it's in your future. Yeah, it's
So
not
essentially, as you're being pulled into the black hole.
Yeah, basically, it's not anywhere in physical space. It's not in the center of the black hole. It's in the future. Like as soon as you enter a black hole, the singularity is in your future, and it is slowly approaching you as time approaches you.
Wow,
basically.
that sounds scary. Okay, third question. Which one theory you wish were true?
I'd say warp drives, like warp drives
Faster
should be
than
real, faster than light travel.
Got
They
it.
should be real.
Fourth question. If you could meet any scientist, living or dead, who would it be?
I'd say it'd be Kurt Gödel.
Okay.
Yeah, so this is the guy. He's more of a mathematician, but he's the guy who proved that math can never be complete. Like math can never be used to prove all statements. That there will be some axioms that will be true and unprovable.
Is the golden ratio an example of that?
No, that's the golden ratio. Like Kurt Gödel is like GODO.
No. I'm asking, is the golden ratio an example of an axiom which...
Well, the golden ratio is not really an axiom. It's just it's just a number, but it's a good irrational number, basically.
Okay. So what, could you just finish what cannot be proven?
Yeah, so things like, for instance, two parallel lines will always be parallel in Euclidean space. How do you prove this? You can only prove by example.
I mean, they can intersect if you just bend that space.
Yeah, exactly. But in Euclidean space, two parallel lines can never intersect. That is a statement. How do you prove it? You can only prove it by example. Like, here's two parallel lines, and like, but can you check all the way to infinity? Like, they don't intersect. What if they do intersect in infinity? You don't know.
Oh my god.
Yeah.
What if they meet a black hole and they just like converge towards the singularity?
And then the space is curved, but in flat Euclidean space, like, there's no real way to prove it
Okay.
without assuming, like, just assuming as a fact that it is true.
Got it. Fifth question. Wildest idea you've ever had?
Well, there's too many, but let me pick one that is understandable to everyone. What I wanted to do was basically make a lunar habitat
Okay.
on the inner wall of a crater. And because craters are circular, it basically travels around the inside of the crater in a track.
Okay.
And doing that creates some centripetal force that creates artificial gravity
Okay.
inside the moon, on the
Wow.
moon. And because it's in a crater, it will always be shaded if it's in a certain region of the moon, like on the South Pole, for instance. So you're going to be protected from radiation, and you're going to have gravity, like Earth's gravity almost.
Wow.
And you can just put up like a solar panel above the rim of the crater and have solar power there as well.
Wow. I have one request. Once you build this, can you name it after me?
Oh, absolutely.
Oh wow! Thanks a lot. I'll chat GPT a bunch of name suggestions and I'll send them over to you. Okay, moving on to the second last section of this podcast. What advice would you give to students who want to combine engineering, science, and entrepreneurship like you plan to do?
Well, my first advice is to have like a good network
Okay.
of people who think like you, people who can help you. And it could be professors, it could be peers, it could be someone in the industry. Just having them on call or having their contact.
Understood.
So when you're doing something, you have a backing for yourself, or you can have someone to help you out because
Wow. Yeah.
because that's the thing that
They might have tried it and failed at it, or
exactly
they have some insights for
yeah
you.
they might know something that you're going through right now, but you don't know.
Wow.
You could just ask them, and it'll save you a ton of time.
Basically learning from someone else's mistakes.
Yes.
Yeah. How do you stay motivated when chasing such ambitious goals? Because dreaming of taking people to Mars And the moon is not something most people are capable of thinking, honestly.
Yes. So how I do it, as I insinuated previously, is by having smaller sub goals that kind of lead up to the main goal. So sort of like stepping stones. Like, okay, I've achieved the small goal, and now I can achieve the next one. Okay, I'm gonna get a software engineering job. That's the second goal, and it's getting me one step higher on the ladder. And that way I stay motivated. Okay, I'm this far up high. There's only like up to go. I can only go up.
Wow, that brings us to the last section of this podcast, which is by far my most favorite one. And this is an open letter to our dear future historians as to what we think the future is going to look like. So, if you go back, let's say, 300 years before the French Revolution, in the era of farmers and peasants and aristocracies and kings and queens, they would have never imagined that in just 200 to 300 years, we would have these metal containers with wheels that could drive us around. There would be no horses. Only the rich would own horses. They would not have imagined that there could be railways or airplanes that could, reduce the time it takes to travel between two places. So, what is it that we as a species cannot imagine right now, but it's going to be a reality in 100 years, of like 500 years, or even 1,000 years from now? So earlier in this podcast, we spoke about Dyson spheres. We spoke about faster than light travel. We spoke about the multiverse. We spoke about a lot of different things. And what, according to Aditya Vikram, is the future going to look like? So let's give you a few checkpoints. Let's say 100 years from now, followed by 500 years from now, and just for namesake, 1,000.
Okay, let me think about it. So, 100 years from now, I think there's absolutely going to be a city on the moon. And there's going to be like at least 10 cities on the moon, let's say.
Wow.
And there's going to be a bunch of construction happening. There's going to be a bunch of nationalization happening. I think the space treaty is not going to last past 2040.
And they're going to be wars?
Yeah, and the space treaty is going to be annulled. And basically countries are going to fight over, okay, whoever gets there first and grabs the most land on the moon, that land belongs to them and to that country, and they can exploit it however they choose. That's going to
America.
Yeah, and China. Like, China is pretty far ahead as well.
Oh, no.
So it's basically a race between America and China. And whoever can grab the most land on the moon, it will belong to them, and it will be like for America, it'll be their next state.
So,
essentially,
just like the Indian brain drain problem, will studying on the moon be a thing?
Yeah, absolutely. For scientists and for radio astronomers and astronomers in general, they're gonna want to be on the far side of the moon because there's no radio emissions on there from Earth. It's blocked by the moon. So you're going to have a really clear picture of the sky in both radio astronomy and all kinds of astronomy from the far side of the moon.
Wow.
So people are going to want to go there.
Okay.
And if it gets really cheap, which I will, 2060, it's going to be like a business class trip to the moon, and it's going to be that cheap. I think that is possible.
Wow.
And that's going to be it.
Wow.
And by 2100, there's absolutely going to be at least 10,000 people on Mars.
Okay.
Yeah.
That's like one city.
Yeah, I'm setting the goal 10,000 at least.
Wow. Okay.
There's going to be basically buildings, industry on Mars. That's the idea. And industry will be beginning on Mars. It'll be beginning to be self-sufficient.
Okay. Yeah. Interesting. And what about faster than light travel, the multiverse?
That's still pretty far away.
Okay.
not by 2100.
All right.
By 2100, I think aging would be a thing of the past for the most part.
Okay.
So people will age really slow by then.
Okay.
There will be cures for most most cancers have already been cured. There's a couple really tough ones, but by then, I think all of them will be cured.
Okay.
And you would be able to grow organs just using the person's DNA, you'll be able to grow a replacement organ and just replace, or like if they have a damaged organ, you can just replace
Wow.
that organ, and it will not have any like rejection because it's their own like flesh.
Wow.
And that way, like old body parts could be like continuously replaced. Like
So we'll
you-
become lizards.
basically, you upgrade your phone every other year, you'll upgrade your arm and leg every other year.
Oh
you'll
my
upgrade
God.
your torso every other year.
Is that 100 years away though?
Yeah, I think it'll happen.
Wow.
I think it'll be expensive, but it'll happen.
Okay,
Yeah.
now let's go to the historians of the year 12,600.
500 years away.
Yeah.
Okay, that's 500 years away. Well, by then, I think the moon will be like completely colonized.
Wow.
There will be by then 5 billion people on the moon.
Okay. And what's the total population of Earth looking like? Or
in
total human population?
in 2500? It'll be like 20 billion or something.
20 billion.
Yeah, because currently the population is stabilizing around 11 billion, but as humans expand to other planets and moons, like there's going to be an incentive again for a big human population to like populate all of those areas. So it's going to explode again. And there's
Wow.
going to be resources coming in from Mars, from the moon. So there's like basically resource shortages will be over.
Got
And
it.
it'll be better for the environment as well, because if you're producing everything on Mars, like if you move all industry to Mars, I think by then it can't happen. You're basically the big problem with industry on Earth is that it pollutes. It creates greenhouse gases, everything, and it basically warms the Earth, which we don't want.
Yeah.
But we want to warm Mars,
Yeah, we do.
so we might as well put it there, and it's gonna do some good. That's the idea.
What if a meteor comes crashing into one of those industries and
Well, that could happen on Earth as well. So
wait, what?
yeah.
Should I be concerned right now?
Well, yeah, it happened to the dinosaurs. It can happen at any time.
So let's say we're going off topic, but if it were to happen again, how much time would we have between seeing a flash of light in the sky and
Well, see,
it obliterating everything?
nowadays we can detect asteroids in orbit like billions of miles away. Like it's not even a problem. We know when something is coming at us centuries in advance, decades and centuries in advance.
Okay.
So that gives us plenty of time to cook something up. Like, are we planning to leave? Are we planning to destroy that asteroid? We could do it.
Deflect it.
Because it's already been done. NASA's
Exactly.
DART mission, like successfully was shot at the moon of an asteroid, Didymos and Dimorphos. Those were two asteroids that were orbiting around each other, and it shortened the revolution period by such a big amount. It was even above what estimated by the scientists. And
But what if this is sort of like a butterfly effect? After altering the trajectory of such an object in space, what if it collides with another object, which then leads to a snowball effect, which leads to a
Well,
bunch of asteroids heading towards Earth?
well, the thing is, everything is so far apart. The chances of something hitting Earth are already pretty small.
Okay.
So even if you change the trajectory and it hits something else, the chances of that thing hitting Earth is even
Wow.
smaller. So
Understood.
instead of
understood.
having a butterfly effect, you're gonna have a negative feedback loop
Okay.
because
okay.
everything is
got
so
it,
far apart.
got it.
So nothing is gonna happen.
Okay.
And like we could just like pick up the asteroid. Like, in 500 years, we're just gonna pick up the asteroid and mine everything, and no longer an issue basically.
Wow. So
Like, if it's
capitalism is
yeah,
there to stay.
Yeah, if it's coming at us, it's
Yeah.
doing the job for us.
Oh wow.
we
I
would
love
be-
your perspective on this.
We'll have been going
We'll have
towards
a
it to
party.
get it anyways. So if it's coming at us, that's good. Great.
Yeah, we'll have like a party, mini party,
Yeah,
a
like-
dinosaur themed party.
Yeah, it's like your dinner cooked itself.
Wow. Now let's go to the year 3100, or I think it's 30. I think it's 13,000, right?
Right.
Yeah, 13,000. And I want you to answer with respect to interdimensional travel, faster than light travel, of course. We know traveling into the future is possible even today, but what about traveling into the past?
Yeah.
And last but not least, teleportation.
Well, I think by the year 13,000 HE, I think we will have warp drives. in faster than light travel in that aspect. As for like dimensions, I'm not really sure. I think that's still going to be like a bit far away at that point.
Okay.
But we will have at least warp drives and like faster than light travel.
Okay.
And we will have at least travel to like Proxima Centauri and nearby star systems.
Okay. And what about the multiverse or going to a different planet, a different universe altogether?
I don't think that's gonna happen so soon. I think it's gonna take a while.
Okay.
Yeah, but I mean, progress is exponential, so it could happen.
And what's the probability of us going extinct because of global warming or maybe World War III in the next few years?
I think if we spread out, we're not gonna go extinct. Like if we have a civilization on Mars, on the Moon, on like some of the moons of Saturn, perhaps further away, we're not gonna have an issue. Like if we have big spacecraft with enough capacity for like 1 million people, like big spacecraft,
Yeah.
they can just go anywhere. Like who's gonna go looking for them?
Right. And the species continues to live on.
Yes.
What if, due to global warming, let's say 20 years from now, before we develop all this space infrastructure, all of humanity goes extinct? And this video is actually being watched by some aliens. And they picked it up just because of its unique name. So what is the probability of that happening? And us being really popular among the aliens?
I mean, the probability of there being aliens watching this and being able to understand it, I think 1%.
What about the golden record? Like, we can transcribe this podcast
Yeah,
into
but the thing is,
a similar
space
form.
is so like vast. The golden record is tiny. Like, I don't think it'll ever like land anywhere near an alien planet. I think it'll just travel forever.
Wow.
Yeah. And as for us being popular with aliens, I think that's 100% chance.
Hey, let's go. I'm sure of that too. Yeah. Well, guys, that's all for today's episode of Dear Future Historians. We've journeyed from the nuts and bolts of Mars rockets to the wildest edges of physics, philosophy, time travel, and everything in between. Huge thanks to our guest, Aditya Vikram, for sharing his vision and curiosity with us. If you enjoyed this, make sure you subscribe and drop a like on this podcast, and join us next time as we explore more frontiers of science, technology, entrepreneurship, and imagination. Until then, keep looking up.